Good morning, everyone. Myself Gautam Sharma, and I welcome you all in a Sapiens Education. For any further more details, you may contact our website or you may visit our website www.sapienseducation.com. Today, as you know that yesterday it was a proud moment for every Indians as our Chandrayaan 3 has been successfully done at a 6-4. Our Vikram landed over at a very accurate pace, and I congratulate to all of you as well as I congratulate to all the scientists of our country and being a proud moment for us. So today I will teach you about the physics laws of motion, that is Newton's third law of motion and impulse, and I will also teach you how these laws of motion help in landing a Chandrayaan. Right. So from for now, today's topic is Newton's third law of motion. What is Newton's third law of motion? To every action there is always equal and opposite reaction. If a body A exerts a force on the body B, and B exerts a reaction force R, and which is equal to minus F on A, and these two forces are acting along the same line. So what does this means? See, every action has equal and opposite reaction. For example, I will just give you simple example. Okay, if this body is kept in a table, okay, this body is kept in a table. So due to weight, this body applies a force due to weight that is equal to mg. So in responding, this table will also apply a force and which is equal to reaction force, and this is also equal and opposite force that is equal to mg. So every reaction in every pair, force always exists in the pair form. Okay, suppose there is a wall. Okay, there is a wall and you took a body like this, and if you apply a force like this, so wall will also apply a same force but in opposite direction. Okay, one thing, it does not matter which body is larger, which body is smaller, both will apply equal force. Even you know that earth, if this is your earth and you there is a small object, and if it applies a force to the earth of amount, for example this body applies a force on earth of 10 newton, so earth will also apply in return 10 newton, right? So this is the thing, understood or not? So it does not depend on the size of the body. Every action has equal and opposite reaction. No matter which body is greater, which body is smaller, all body will apply each force to each other at equal amount. Now let us consider this is a body A and this is a body B. Okay. Now both are in motion. For example, it has velocity UA and it has velocity UB. So both are in motion and both collide. Both body gets collide. It means that force has been exerted by A, force on B by A. This is your force exerted by body A on B. Force exerted by body A on B. So in this way you can write, if it is written F AB, that is force exerted on A, due to body B. So this is what Newton's third law states. Okay, so again I will show you from some examples. See here, a person is just applying a force from a figure. You can see here, you can see this person is applying a force, okay, of a 500 newton. Then the opposite wall is also applying a force of a 5 newton only. In case of wall, if you replace it with the elephant also, then also if person is applying a force of 500 Newton, then the elephant is also applying a force on 500 Newton. Understood? This is how equal and opposite force act. Now see this figure. This figure above in this this red color mark you just see. What happens? So I want to show you this figure. Okay. See this figure. I want to show you now this figure. Okay. Try to understand this figure. What this figure signifies? See, there are two person, one and two, and both are on what frictionless layer. Okay. Now, see the person on the left side is having a ball. He throws a ball. When he throws a ball, what happens? When he throws a ball, what happens? Understand. Try to understand here. When he throws a ball, it means that this person A and this is a person B, both persons are standing, and when person A is throwing a ball, it means that person A applies a force. Person A applies a force on ball. Person A applies a force on ball. Okay. In result, ball also applies a force on the person. Ball also applies a force on person. When this ball applies a force on this person, so what will happen? As you know that this is your frictionless layer, so when person applies a force on a ball, so ball also applies a force on a person, and due to this force, the force applied by the ball makes the person to move backward. And same thing in right side also. A person, if he throws a ball, so ball is applying a force to this right side person, and he just move backward. Okay. Now here see figure of a boat. You see here boat. See here a person is running on a boat, and the person tries to run in a boat. Okay. Person applies a force on a boat. As a result, boat will also apply a force, and that force, due to that force, only person able to jump to that nearby. Okay. So this is what happening. Third example I am showing you. See here, a person A and B both are applying force on each other, but both are equal force. Okay. Now the most important example. See here. What happens here. See this is a Bikram lander, and there is a gas is coming out. Okay. So when gas is coming out, it means that it is like a ball only. So it is throwing a gas. It means it is throwing a mass. It means that this applies a force on this gas. When it applies a force on this gas, then gas as a result applies a force on this. Okay, and due to this will move upward direction. So this is there is also a case of a rocket propulsion also. So everywhere you will find that as per the Newton's third law, every action has equal and opposite reaction. Okay, I hope you all guys have understood what actually I want to make you understand about Newton's third law. Now see, action and reaction act on a different body, and hence they never cancel each other. See, very important. This is very important. This line is. We know that every action has equal and opposite reaction. So, for example, a person is here. A person is standing here and try to apply a force on this object to move this object. But if person is applying a force of 10 Newton, then object is also applying a force on 10 Newton. So total force, that is F net, will be equal to 10 minus 10, that will be equal to 0, because both are equal in opposite direction. So if net force is 0, so is it possible to move the is it possible to move this box? No, as per this, no. But the thing is that most of the students does it wrong. Why wrong? Because when we calculate on net force, it does not. It means that we should take any object, okay, and we must take the force which is being applied on this object. We can't take that force which is being applied by the object. Always take the force into the account. Always take the force into account. The type of force is being applied by force is being applied on the object only, applied on the object. Don't take the force applied by the object. So in this case, what happened, if you will look at this object, so see here I am showing you, just this is your box, okay. At this box a person is applying a force of 10 Newton. We only account for this, we will take this force only. We don't need that force which is applied, force is applied by this object, only to this object. So this 10 Newton force is there. So suppose it is on the ground. So let us consider friction force may be 5 Newton is there. So total net force is how much? Net force will be 10 minus 5. So this will be 5 Newton only. So by the help of this 5 Newton, this object will move. Understood? I hope you all will not do this mistake again and again. Okay, so we only account for that type of force, the force which is acting on the object, and in this way we will able to solve each and every problem. I hope you all have understood this. Now the very important topic is impulse. I hope you all have learned or heard about impulse. What does impulse means? When a large force, see, when a large force for an extremely short duration, neither the magnitude of the force nor the time for which it acts is important. In such a case, the total effect of the force is measured. See, when very small period of time a large amount of force act, then the effect produced is known as impulse. Okay, we don't care about how much force it is, we don't care about how much time it is. As you know that I will show you the case of impulse. See what happens if this body, very large body, applies a force for 1,000 years. So you don't you don't will able to see here so much impact. Okay, but if a force for a small duration of time with a high velocity will create a problem, like create an impact, create an impulse. See, from example I will show you. See, this player when he gets a ball, then suddenly he applies an extra force for a short duration of time, because football player and ball, see that highlighted mark, ball and football player, they both have interaction of only few seconds. But when he applies a large force, then it creates an impact. Okay, and due to this it went into the goal side, and this is the example of impulse. So for impulse, force and time is very important. For a short duration of time, if force is acting, so that type of effect is known as impulse. So impulse can be defined as impulse I is equal to force into time. Okay, just you multiply it by time. Impulse is a total effect of a force is called impulse. Okay, a large force act on a body for a small time. Force should be very large, it should not be small. Okay, so this is the condition. So if you will go for an integration, then impulse can be written as, I don't know how much force, it may be variable, and I don't know about time, so we should try to integrate like this, T1 to T2, force F into dt. Understood? So this is what we can write for impulse. Okay, and sometime we can also write here like this. Impulse is equal to, see, I will show you some derivation. See, impulse I is equal to, I have already discussed about this, F dot dt. Okay, and from T1 to T2. Now we know that F is your what? F is your rate of change of momentum, that is dt by dp by dt. So can we write here, just in place of force, as we don't know what force is constant or variable, so can we write here T1 to T2, in place of T1 to T2, in place of I need an eraser. Okay, sorry. Okay. See, in case of a force, we can replace here dp by dt and into dt. So this dt get cancel out, and what we have a limit? We have only limit of a momentum, that is equal to p1 to p2. So impulse I can be written as integration of dp from p1 to p2, or we can write here dp, integration of dp will be p, and it just put a limit of p1 and p2. So what we will get? We will get p2 minus p1. Okay, so this is known as impulse. I hope you have understood this. So impulse is the change in momentum. Impulse is the change in momentum. The amount of momentum has been changed. See here, see, ball is coming to this player, red color player, and suddenly he hits the ball and the direction of ball suddenly changes. It means that there is a sudden change in the momentum of ball. Understood? And this is called the impulse. Okay, hence impulse for of a force is equal to change in momentum, and it is also known as impulse momentum theorem. So this is very important for you all people. What is impulse momentum theorem? So change in a momentum is known as impulse. So this is very important. Okay, so we will use in solving a numerical. Now if force is average, we know that force is an average magnitude, then we can write like this. Why? Because force is constant. Average means constant we have taken, and T1 to T2. So force impulse can be also written as average force into change in time. So this is very important. You can solve numerical from this also. And if force is variable, see, if force is variable, then don't use this formula. But if force is variable, use this formula. Okay, but if force is constant, or you have found out that average force is this, so definitely you go for this. I hope you have understood. Could you please tell me the what is the unit of impulse? Unit. So you know that unit is how much? Force has a unit what? Newton, and time is second. So Newton second. It will be Newton second only. I hope this topic is clear now. Now, the important topic is law of conservation of linear momentum. Law of conservation of linear momentum. What does this means? See, law of conservation of linear momentum. If no external force acts on the system or isolated system, a constant mass, the total momentum of the system remain constant. See, if an object is there, okay, and it has some momentum. Suppose it has velocity v, it has a mass m, and it has initial momentum is equal to mu. Okay, no external force is acting on this system. No external force is acting on this system. No external force acting on the system. on the system, so its momentum will remain same, the product of mass m into u. It may be the case that here mass may gets divided into two parts. Okay, so it may break. So for example, initial momentum is your 100. Now when it break, so its mass become m1, its velocity become u1, v1, and this mass, another mass has a mass is m2 and velocity is v2. Now you need to find the total system. Since there is no external force are there, so total momentum will be what? After time, total momentum, total P will be what? M1 V1 plus M2 V2, and this will remain constant. Means what? If initially it was 100, then finally also it has 100 momentum. This is the statement of law of conservation of momentum. Understood? So momentum, total momentum of the system will remain constant. When a bullet is, see, I will give you some example. When a bullet is being fired, bullet is fired from a gun, total linear momentum is conserved because net external force on the system, gun plus bullet, is zero. See, try to understand here. What they are telling, what is this? See, if there is a gun and there is a bullet inside it. So initially it has some momentum. Now after firing, bullet will may come outside and gun will be here. So total momentum of these two body, we will consider these two body as a system because initially they were a part of system. After a firing, it is also a part of system. So what will happen? So definitely its momentum. For example, initial momentum of gun and bullet, you know that both are at a rate, so initial momentum is zero. Now here also total momentum will be zero. How? Let us consider mass of, this is a mass of a gun and this is mass of a bullet. This is the velocity, final velocity of a gun, and this is the final velocity of bullet. So see, you know that gun will move backward and bullet will move forward. Okay. So now total momentum will be how much? Total momentum of both the system will be mass of gun, velocity of gun, plus mass of bullet, velocity of bullet. So as you know that initially total momentum was zero, so finally also total momentum is equal to zero. That means that mass of gun, velocity of gun, plus mass of bullet into velocity of bullet, this is equal to zero. This is equal to zero. Okay. So finally, we get finally we got some conclusion. What type of conclusion? See here. If we will solve this equation, so mass of gun, velocity of gun will be equal to minus of mass of bullet into velocity of bullet. Okay. So see, both both are the product of momentum, but both are in opposite direction. If bullet is moving forward, so gun is moving backward. So total momentum of the entire system will remain constant. This is what about law of conservation of momentum is. Understood? As there is no external force in the this system, I will show you with some example. See here, in rocket propulsion, initially it was at rest, but when it gets launched, so total momentum of both the system will also remains zero only because initially it has some momentum, so finally it has also same momentum will be there. So try to understand this, what actually it does mean. See, wait, I will show you by just explaining one thing. Okay. uh wait. Hmm. Now see, try to understand here. Suppose this is our rocket. This is our rocket launcher. Okay, this is a rocket launcher. Okay, and it is at a rest initially. It is at rest. Okay, it means that mass of the rocket is suppose m, velocity, initial velocity is u is equal to 0, and mass is equal to, mass is m. So initial momentum is how much? M into u, and that will be 0. Now in case when it got launched and it just start going in upward direction, what happens? See, gas also coming out. Okay, so suppose mass of the rocket is m and velocity is v. Mass of the rocket mr, velocity is v, and suppose velocity of gas is v, and mass of the gas is g. So total momentum, see here, initially total momentum was what? 0. Final momentum, total momentum at final condition, total momentum at final condition will be what? Hot. So first of all, take the momentum of the rocket, that will be mr into velocity, plus momentum of the gas, that is equal to mg into velocity, and this will be equal to 0. Understood? So you will get relation like this: mr into v is equal to mg into v. Velocity may differ. See here, velocity of, you can take velocity of gas here vg, velocity of rocket as vr. So you can write here also like this. Okay, no need to. So no need to take only v only. You have to take velocity of a rocket like vr, and velocity of gas is vg. But this is in minus symbol. So by this relation you will able to understand what actually means is. So here total momentum at a final condition is 0. So while solving a problem, you will get a lots of relation here. So you will able to find actually what, how to find the velocity of the rocket, how to find how much mass of the gas is required and all. So I will give you some example of rocket propulsion system. Okay. So see here what is actually rocket propulsion system is. The initial momentum of the rocket on a launching pad is 0. You know that initially it was red, so no momentum is there. Neither it has gas has velocity, and neither rocket has velocity. When it is being fired, exhaust gas rush downward at a high speed and conserve the momentum, and the rocket moves upward. So as gas comes out, means what? Rocket is applying a force on gas by a rocket, and in result, as per the Newton's third law, gas is also applying force on rocket by the gas, and both are equal and opposite, right? Both are equal and opposite. So either it is being applied by gas, or either force is applied by the rocket on the gas. Both are equal. Okay. So it is also known as thrust. So what actually thrust is? See here, thrust on the rocket F is equal to minus v dm by dt. Why it is written minus v dm by dt? See, force, you know that force is in the negative direction. Thrust on the rocket means what? Force applied by the gas on the rocket, and this is equal to F, and this is equal to minus of velocity of the gas or velocity of the rocket into dm by dt. Okay. Why I have written this? You need to understand here. As we know that force is equal to rate of change of momentum. Okay. But here velocity is constant. So we know that P final minus P initial divided by time t, we can write here. But we know that mass is changing but velocity is constant. Mass is changing but velocity is constant. So can we write here mass in mass into, can we write here mass into velocity? Let's see mass into velocity mv minus mu by t, or we can write here velocity is constant. Since velocity is constant here, so we can take out velocity here, and mass is not constant. Why mass is not constant? Because it's just coming out of the rocket. So you can write here dm by dt only, and this is what force is, exhaust forces. So earlier you have understood that force is equal to mass is constant dv by dt. Okay, but now velocity is constant but mass is changing. Why mass is changing? Because every second gas is coming out, and as the gas is coming out, the mass of the whole system will decrease. So that's why we have written dm by dt, but with the minus symbol, because mass of the rocket is decreasing every time. So that's the force. Force is equal to velocity into dm by dt. By using this formula, you can calculate of thrust on the force. Understood? The more the rate of change of mass, the more gas is exhausting very high, the more force will be, more thrust will be applied on the rocket. So if you want to increase the velocity of the rocket, so you need to increase the exhaust speed of the exhaust gas. Okay. Now how you will find acceleration? So you know that acceleration is equal to force by mass. So here thrust, force is thrust is what minus v dm by dt, and please divide this by m, so you will get minus v by m dm by dt. So by using this formula you will able to calculate acceleration. Okay, so hence velocity of exhaust gas, dm by dt is a rate of fuel consumption, and rate of ejection of the fuel. That is, the rate of fuel consumption is equal to rate of ejection, because the more it will consume the fuel, the more it will eject the fuel. Understood? So this is how rocket propulsion works. Okay, I hope you all people have understood this. I hope you all people have understood this. So I will end this class, and I will come with the numerical and problem, lots of problem. I will come with the lots of problem, and if you watch more and more video, then I will definitely come with the NCERT problem solution also. And I hope you all have enjoyed my classes. Thank you everyone.